Welcome back, guys. Now in this video let's discuss about compliance and elastance. Okay, now usually people think that elasticity means stretchability. People think like this. So if you go to them and if you ask them what exactly is elastic, they will say, now if it is stretching, it is elastic substance. But here in respiratory physiology, or when we are discussing about lungs, that's totally opposite. If something is more easily stretching, then we will say it's having more compliance. So compliance is the other term or synonym for stretchability. Okay. So stretchability is the other term for compliance. Then what exactly is elastance? Elastance is recoiling force. Okay, or I should say ability to go back to original shape. So property or ability to go back to its original shape or a property to resist deformation is called as elasticity. In a simple word or in a simple example, we can say, just take a rubber band. Now stretch it, it's going to expand or not. Now the stretching is called as compliance. If it is more stretching means we will say it's more compliant. Now when you leave it, it will go back to its original shape or it will go back to its initial position. So going back to its original shape, that property is called as elasticity. So elasticity means going back to its original position or original shape. Now if you see this pen, now is it more compliant or more elastic structure? Now I am trying to stretch it. Is it stretching? No, the compliance of the structure is less. But what about the elasticity of this pen? What about the elastic nature? See, it is resisting deformation. It is resisting the deformation. Now it is not stretching. It is trying to preserve its original shape. So we can say it's having more elastic nature. Okay, so compliance and elastance are opposite to each other. Okay, very important point, guys. Take a note. Compliance and elastance, they are opposite to each other. Compliance and elastance, very important point, they are exactly opposite to each other. Okay, having discussed that, we can also say compliance is inversely relational to elastance. Now after discussing this, let's talk about the formula for compliance. Okay, in a formula, the compliance is defined as change in volume, that is delta V, change in volume by change in pressure. So change in volume by change in pressure, that is delta V by delta P, is giving us compliance. So compliance is equal to delta V by delta P with a unit change in pressure. If you change the pressure, for example, if you increase the pressure, if volume is also increasing for a given pressure, see, if you give a little pressure, if more volume is changed means we can say the structure is more compliant. Even with giving pressure, if there is no change in volume, then we can say it's less compliant. So compliance is nothing but with a given pressure or with a little change in pressure, how much volume is changing. So that gives us compliance. Okay, delta V by delta V. Now let's see what is the normal value, okay, of compliance, okay, of lungs. What does I mean by what is the compliance of a lung? See, the compliance of a lung is 200 ml per 1 centimeter water pressure. Now, if you give this much amount of pressure, delta P, this much volume of lungs are going to expand. With a given pressure, this much volume of lungs are going to change, or this much volume of air is going to enter into the lungs, or this much volume 200 ml of lungs will be expanded. So, with this much given pressure, if you give 1 centimeter of water pressure, 200 ml of lungs, okay, 200 ml, that much volume of lungs will be expand. So, this is the normal value of compliance of the lungs, okay, this is the compliance of lung, 200 ml per 1 centimeter of water pressure. Now, see, let's talk about a condition which is called as emphysema. Now, in emphysema, what's happening? In emphysema, there is decrease in elastic recoil due to destruction of elastic fibers. Now guys, we all know in the alveolus there are these elastic fibers, and those elastic fibers are the ones responsible for collapsing of the lungs. Now, in emphysema, the person is a chronic smoker. He eventually developed emphysema. Now, what is happening because of the smoke and all the stuff? Now, the elastic fibers in the lungs are destroyed. Now, when the elastic fibers are destroyed, what happened to the elasticity of the lungs? Elastic recoil of the alveolus. The elastic recoil is lost because of the destruction of elastic fibers. Now, whenever there is no elastic recoil, whenever the collapsing force is taken out, now with a given pressure, lungs will be more stretchable. So, in emphysema, what happened to compliance? Compliance increases. Okay, very simple. Now, you have taken out the elastic fibers. Whenever there is no elastic fibers, there is no recoiling force or there is no collapsing force. Now, with a given pressure, lungs or the alveolus will become more stretchable, or lungs will become more compliant. Now, let's take one more condition where now you have to tell me, see, I am showing you alveolus here. Now, what I am doing is, I am keeping more and more fibers here. I am just depositing more and more fibrotic material or fibers. Okay, more and more fibers are getting accumulated here. Okay, now, what is this condition? This condition is pulmonary, okay, fibrosis. Okay, in the condition of pulmonary fibrosis. Now, just tell me what happened to compliance or what happened to elastance? Guys, as more and more fibrotic material is getting deposited in the lungs, now do you think it is easy to stretch the lungs? No. Because of the pulmonary fibrosis, now the alveolus are not easily stretchable because of more fibrotic material. Now, elastance increases. So, whenever elastance increases, automatically what happened to compliance? Compliance decreases. Okay, this is what you need to know. Now, after this, let's talk about two types of compliance. Okay, guys, I want you to know different types of compliance. Here itself I am writing you types of compliance. There are two important types of compliance which you need to know for your exam. The first type of compliance is called as static compliance, and second type is dynamic compliance. In the name it is there. Static means no motion. Dynamic means there is motion. What is this no motion motion? Very simple. Now, whenever you measure the compliance of lung during resting state, there is no inspiration, there is no expiration. Static. Now, whenever you measure the compliance of lung when the person is holding his breath during rest, that is called as a static compliance. So, static compliance, just take a note, measured. When it is measured? Measured during no air flow. Whenever there is no air flow, no inspiration, no expiration, or we can say during breath holding. Okay, so direct question is, what is the compliance that is measured during breath holding? It's a static compliance. And what is dynamic compliance? And what is the importance of this dynamic compliance? We will know whenever we are discussing the pressure volume loops in a minute. Okay, now dynamic compliance is compliance measured during airflow. Okay, or we can say during inspiration and expiration. Okay, now after discussing the basics about the compliance and elastance, now let's see or talk about the pressure volume loops. Guys, don't confuse this with the flow volume loops. Flow volume loops are totally different, which we will discuss later. Right now we are discussing about the pressure volume loops. Pressure volume, okay, changes, pressure volume changes. See here on x-axis I am showing you pressure. Which pressure? Intrapleural pressure. And on y-axis I am showing you volume, okay, volume of the lungs. So here I am showing you the changes in the pressure, that is delta V. Here I am showing you changes in the volume, that is delta V. Sorry, here there is delta P. Okay, changes in the pressure, that is delta P. Here it is delta V. So delta V by delta P is nothing but compliance. Yes, right? So right now we are discussing about pressure volume loops, which is nothing but the measure of compliance of lungs during inspiration and expiration. Okay, now let's start from the intrapleural pressure. Guys, I just want to make little changes in the values, which here whatever the values given in this graph are little different. Now let's take it from minus 2.5 during rest. What is the intrapleural pressure? Minus 2.5 mmHg, and during inspiration it will go up to minus 6, right? Okay, after saying this, please concentrate. During inspiration, what is happening? Right now I am talking about the inspiration. During inspiration, see the curve is going like this, which means the air is entering into the lungs. Okay, the compliance curve is coming something like this. Okay, don't worry, everything will be very much easy. Now at minus 2.5, any air is entering into the lungs? No air is entering into the lungs. There is no volume change. Okay, there is zero volume change. Okay, let me write it down. Minus 2.5, that is at rest. Rest, is there is any air entering into the lungs? There is no air entering into the lungs. So there is no volume change. But with inspiration what is happening, guys? With inspiration, the intrapleural pressure is becoming minus 6. So what's happening to the lungs? Lungs are expanding. The volume of lungs is changing. So see here, the volume of lungs is increasing like this. Okay. Now during expiration, what will happen? From minus 6, the pressure will again come back. So lungs will be collapsing. Same lungs will be collapsing. So what happened to the volume of the lungs? Volume of the lungs will come back. Important point to note here is that, see, the path of inspiration and the path of expiration, they are not the same. It's not the same path. The path of inspiration is different and the path of expiration is different. Means the volume changes in the lungs during inspiration is different and the volume changes during expiration in the same lungs is different. Okay, so the amount of volume which is changing during inspiration is different and during expiration is different. The paths are not the same. So this difference is called as hysteresis. Now, why there is this hysteresis? Why there is a difference? Okay, or I can say why there is a difference in the compliance of the lung. Why? Because this is a compliance graph. We can very clearly see the compliance during inspiration and the compliance curve during expiration are absolutely different. Now, why this is happening? Now, the difference hysteresis is because of surface tension. Okay. Very, very important point. The surface tension in the lungs will change during inspiration as well as expiration. Now, let's see some important points which you need to know. Okay, just don't worry, everything you will understand one by one. Let's see. First of all, this is the compliance curve of inspiration. This is the compliance curve of inspiration, and let me draw it with a different color. This is the compliance curve of expiration. Of same lung or different lung? Same lung. Now, my question is, compliance is more during inspiration or expiration? First question. Compliance is more during inspiration or expiration? Now, most of the students, they will think, during inspiration, lungs are expanding, so compliance is more during inspiration. They will think like that. But no, compliance is more during expiration. How can we know from this graph, and how can we know that from the theory in a practical way? See, for example, at this pressure, okay, at -5 intrapleural pressure, what is the volume change in the lung? See, at this pressure, let me draw a line here like this. At -5 intrapleural pressure, the volume change in the lung is somewhere around, for example, let's take it 50 ml. But at -5 intrapleural pressure during expiration, see, during expiration, the volume change is somewhere around 350 ml. Okay, now with a given pressure of -5 mmHg, where more volume is changing? The more volume is seen during expiration. The more lungs are changing their volume more during expiration when compared to inspiration. So, when lungs are more compliant, sir, lungs are more compliant during expiration but not during inspiration. Why? This difference is called as hysteresis. Now, why there is this hysteresis? That hysteresis is because of surface tension. Now, let's explain why the surface tension causing the hysteresis. To understand this, just have this example. See, not just example, this is what happens in the lungs. During inspiration, and during expiration, what's happening? What are the changes in the surface tension? During inspiration, I have taught you the compliance is less. Compliance means the stretchability is less. Why the lungs are not stretching? Because during inspiration, surface tension is more. More surface tension means less compliance, because surface tension is a collapsing force. During inspiration, in the lungs, in your lungs and in my lungs, surface tension increases. Surface tension is a collapsing force. It resists the stretchability. It resists the compliance. Now, why surface tension increases? We will discuss, don't worry. But during expiration, okay, during expiration, surface tension decreases. As surface tension is decreased, now collapsing force inside the lung during expiration decreases. When the collapsing force decreases, now lungs will become more stretchable. So, we can clearly say that, sir, during inspiration, surface tension is more. As the surface tension is more, the compliance is less. During expiration, the surface tension forces in the lungs decreases, so that compliance will be more. Now, you will get a doubt. Sir, why there is this change in the surface tension during inspiration and expiration? It's the same lung. Why surface tension is getting increased and decreased? Now, I will explain you here. See guys, I am showing you one alveolus. Now, you all know, inside the alveolus, who is there? Inside the alveolus, there is this one special molecule called as surfactant. Okay, this red color molecule is called as surfactant. Now the surfactant, what is the function of the surfactant? Surfactant reduces the surface tension, we all know. Now let's see what happens during inspiration. During inspiration, the alveolus are expanding. The alveoli are becoming bigger. Now when the alveoli are becoming bigger, what happened to the concentration of surfactant molecules? Now the surfactant molecules, the number is same, but the concentration of surfactant molecules, now they are becoming more wider. Okay, the surfactant molecules are placed far from each other. So what happens is that because of the less concentration of surfactant, surface tension in the lungs increases. So during inspiration, because of the lesser concentration of surfactant, surface tension increases. So when surface tension increases, collapsing forces increases. Collapsing forces increases means compliance decreases. That is the reason why we can see here in the pressure volume loops, during inspiration, the compliance is lesser. Now, during expiration, what will happen? During expiration, see, the lungs or the alveoli are becoming more smaller because they are collapsing, right? Now, whenever they are collapsing, see what happened to the surface tension concentration? Yes, even though they are collapsing, the surface, these molecules, surfactant molecules, now they are becoming closer to each other. The concentration of surfactant is increasing. When there is enough amount of surfactant, what happened to the surface tension? Surface tension decreases. So whenever surface tension is decreased, collapsing forces also decrease. So whenever the collapsing forces are decreased, what happened to compliance of lung? Compliance of lung increases. So during expiration, compliance increases, and during inspiration, okay, here during inspiration, compliance decreases. Okay, compliance decreases because of more surface tension. Okay, so this is the pressure volume loop which you need to know. The difference between the paths of inspiration, or I should say the difference between compliance during inspiration and the compliance during expiration is called as hysteresis, and that hysteresis is due to surface tension forces. Now, after discussing this, let's talk about a very important concept. You should try to answer it. Okay, you guys try to answer it by yourself. What happens to compliance of lungs which are filled with saline? Okay, saline filled lungs. Now the lungs are filled with saline. Now what happened to compliance of the lung? Compliance of the lung decreases or the compliance of lung increases? Just think logically. So whenever you fill lungs with the saline, what's happening? The entire lung is filled with the saline. Now in the entire lung there is water. Okay, there is no air. By putting saline here, what you have actually done? You have taken out the air, you have removed the air out. Now there is no air-water interference. In a normal lung, see, in a normal lung, there is thin water film here, thin water coating will be there, and here will be air. So in a normal alveoli or in a normal lung, there is air and water interference. Okay, air and water interference is there. So wherever air-water interference is there, there develops a force called as surface tension. But in a saline-filled lung, what you have done? You have filled the alveoli entirely with the saline. So there is no air and water interference, or interface is not there. Okay, only what is there? Only fluid is there. So what you have done in a saline-filled lung? In a saline-filled lung, you have taken out the surface tension. There is no surface tension, or we can say there is less surface tension. Now whenever there is no surface tension, what happened to compliance? Compliance of lung increases. So compliance of lung in a saline-filled lung is more. The lungs will become more compliant because you have taken out the surface tension. So if I have to show you that pressure volume loop, okay, it will be something like this. In a saline-filled lung, the compliance graph will come something like this. Okay, Here, this is the compliance curve of saline-filled lung. So, during inspiration and during expiration, is there a much change in compliance? There is very less change. In a normal lung, there is a big change in compliance. That change is called as hysteresis, and that change is because of the surface tension. But in a saline-filled lung, there is no surface tension or less surface tension. Because of that, the compliance of a saline-filled lung is more towards the y-axis. If a curve is moving more towards the y-axis, then we can say that curve is having higher compliance. Even in here, in a saline-filled lung, the curve is more towards the y-axis, which means it's having more compliance, and the difference, that hysteresis, is also negligible because there is no surface tension. Okay, this is what you need to know. Now, after seeing this, just try to answer these two important graphs. Okay, see here. Let's take, this is the normal compliance. This dotted line is a normal compliance. Okay, of course we know the compliance during inspiration and expiration is different, but let's take in a one single graph. Okay, in a one single line, this is the normal compliance. Okay, now this is normal. See here, they are showing you one graph with a blue color line. Now, simply tell me, here compliance is increased or compliance is decreased? If the graph is moving towards the y-axis, I have taught you, the compliance will be increased. So, this graph is showing you lungs, these lungs, whatever I am talking right now, these lungs are having increased compliance. How can we say? The graph is more towards the y-axis. Now, what are the conditions in which the compliance of the lungs will be increased? One example I have already gave you, that's the saline-filled lungs. Saline-filled lungs are having more compliance because you have taken out the surface tension forces. Now here, the example which we are discussing is emphysema, emphysematous lungs. Okay, chronic smoker, his elastic fibers are destroyed. Whenever the elastic fibers are destroyed, there is no recoiling back. The recoiling forces or the collapsing forces are gone. Just like surface tension forces, elastic recoil is also a collapsing force. So, whenever you have destroyed the elastic fibers, there is no recoil of the lungs, there is no collapsing of the lungs, there is only, now that lungs will be easy to stretch. So, emphysematous lungs are having more compliance, okay, more compliance. And here we can see that this graph is moving more toward the x-axis, it's falling down. Now we can clearly say here the compliance is decreased now in these lungs, okay, total different lungs, total different pathology. Here the lung compliance is decreased. When the lung compliance will be decreased? When the lungs become fibrotic, okay, when the alveolus become fibrotic, now it will be very hard to stretch those lungs. Now, what are the conditions in which you will have this decreased compliance? I have already taught you. In the conditions like pulmonary fibrosis, okay, pulmonary fibrosis, and the conditions like total collapsing of the lungs, that is atelectasis. When, very important example is pulmonary fibrosis, okay, let me write it down here, pulmonary fibrosis. Okay, now in pulmonary fibrosis, the alveoli are getting fibrotic, so it cannot be easily expanded. So the compliance of lung is decreased, so that the curve is falling more towards the x-axis. This is a normal compliance. How can we say? If you ask me, sir, how can we say that a fibrotic lung, or the person who is suffering with atelectasis, or the person who is suffering with pulmonary fibrosis, he will be having lesser compliant lungs? How we can say, sir? See the graph here. The pressure is 15. Okay, intrapleural pressure is 15. Now, normally, whenever a pressure of 15 is there, intrapleural pressure is 15. Now, in a normal person, what is the volume change? The volume change is somewhere over here, 300. Let's take 300 is the volume change in a normal person. Okay, this is just an example. But in a fibrotic lung, okay, the volume change is somewhere just around 50. Or even in expiration also, even in expiration, the volume change is somewhere around 250. So, all the time in a fibrotic lungs, the compliance will be lesser when compared to normal. Okay. Guys, I have discussed all the important graphs and concepts which are needed in the topic of compliance and elastance. Okay, again I am repeating, simple. What are the collapsing forces in the lung? The two important collapsing forces in the lung are surface tension forces and lung recoiling forces. So surface tension forces and recoiling forces are the ones responsible for the elasticity of the lung. Okay, and the compliance is inversely proportional to elastance. If compliance increases, elastance will be decreased, or if elastance increases, automatically compliance will be decreased. Okay guys, we have discussed all the important points about compliance and elastance. See you in the next video.